workshop video of foundry, that is where a mold or cavity was produced using one pattern, replica. Pattern is nothing but the replica of the object to be produced. So preparing that replica, some cavity was produced using molding material, and in that workshop, molding material was green sand mold. So our workshop actually utilizes green sand as a molding material. So that's why this is also known as green sand molding. Then cavity was prepared, and then after the preparation of the cavity, the task is to pour molten metal. So that was not demonstrated, and it is not done actually in our workshop. Though in the recent time, we have one furnace, melting furnace, electric melting furnace for light metals, aluminum, etc. And occasionally some demonstrations are given, but that is almost newly installed. Before the lockdown, during the end of 2019, that aluminum melting furnace, electric furnace, was installed. And now, if possible, in future, maybe demonstrated how the metal is melted and then it is poured inside the cavity. So that is the pouring of molten metal. But that is not a regular or usual task in your workshop. So after preparation of the cavity, molten metal is poured and allowed to be solidified. So as soon as the molten metal solidifies, then again the mold will have to be broken, and that part will be taken out, and then cleaning, finishing, all these, if necessary, are to be done. Heat treatment for improvement of some properties. You know what is heat treatment. In material science, you have learned. So this is all about the foundry shop. Now here again, there are so many things to be discussed. Now we have observed the practical part after some initial discussion on theoretical portions, tools and accessories needed, and something on the theoretical portions. Then some practical job was prepared. And in your theoretical class, I think simultaneously the theoretical classes are also going on. I am taking the other section.
Sir, our manufacturing class is still not started, sir.
No, that will be started because somebody is responsible to take care of your manufacturing process. So things will be started later on. So obviously those will be discussed at length, all the theoretical, because it requires number of classes, some syllabus is there. So accordingly, those will be discussed. And in a practical, it is not possible to discuss in detail all about the theoretical things, right? Similarly, in our section, that is, I have one section, maybe B, where we have already started that theoretical aspects. So in your section also, theoretical discussions will be going on after some time. Okay. So in this way, but here we shall touch some salient which are essential minimum, both in foundry as well as in forging. Other workshop will be on forging. So now we have observed the foundry video. Now I told you that you have already that link. You may utilize the link a number of times. So you go through that videos time and again. Otherwise, it is not possible. Only one observation may not be sufficient. So I hope that in the meantime you had undergone through that video, and also you had undergone through some books also. That is also needed. I have mentioned about some books. So you procure some books, both for that is important, both for your theoretical classes also, and also for these workshops. So now we shall discuss something more theoretical things today on Foundry. But before that, as you had already observed the video, and perhaps you have gone through some books also. So do you have some queries or clarifications to be clarifications needed on those portions, or on forging Foundry at large? So tell me. Hello. So do you have any queries, clarifications on those? If you don't have, then we are starting our today's discussion. So, so molding sand is the material. Now all of you are getting the slide.
Yes,
So
sir.
molding sand is the material in our foundry, and what is molding sand actually? Molding sand is nothing but dry silica sand actually. Silica sand, uh, almost the quantity may be 80 to 90 or many more. So uh, either granular quartz sand, or some other type of rocks. Actually, sand is nothing but fragmented rocks, mountains. Okay, so years after years, that is after prolonged, say, for a prolonged period of time, not a 10 years, 15 years, 100 years, thousand crores of years, years after years. Okay, so decade after decade. So due to natural calamities, like say earthquake, severe storm, flood, rain, lightning, all these. So different type of say natural calamities, etc. Due to all these natural calamities, the mountain, uh, the rocks actually are fragmented due to wear and tear, and the smaller particles, what we are observing in the recent time is the concept of sand. So sand is coming from some basic mountain or basic rock. So accordingly, it has got different names. Say quartz rock, quartz sand, silica sand. So many other types of rocks are also available in nature, in not only in a single place, but in different places. Accordingly, the sands are having different names as well as different qualities depending on the type of or nature of the rock. Okay, and also the particle size, sand particle fragmented rock. This is a fragmented rock, but the particle sizes are not all same. It is a mixed mass. So there are some larger particles. There are some medium pieces, some smaller fragments, and some powdery mass also. Okay, so that is a mixed mass of different shapes as well as sizes. Both sizes are different as well as shapes are also different. Not all the particles are circular or square or rectangular or pentagonal. What else? So it may have different shapes and sizes, some powdery mass. But so in a handful of sand, if you take one handful of sand, not all the size particles shape and sizes are same. It is a mixed mass. Okay, but how to then measure the approximate size? Not shape. We don't bother about shape. Now size, the one measure is there, that is the grain size is given by one grain fineness number. That is a concept. That is a later on we shall discuss in our theoretical classes the how to measure the grain fineness number. Okay, so in a say handful of sand, the approximate size, if this is a mixed mass, there are various sizes from powdery mass to larger fragments to smaller, medium, etc. But I should mention at least somehow what is my requirement. Like say in a construction work, if you are familiar with some construction work, when the columns or bases are casted, reinforcement, your RCC structure for RCC structure. Okay, so those require for casting very your coarser sands that will give you very hard structure. On the contrary, if you want very smooth surface finish, like say plaster of the walls, finished walls, then finer sands are required. So I should mention that this is my requirement, coarser or medium coarse or fine, and there is a measure that is the grain fineness number. Grain fineness number. So how it is done, what is the meaning, those will be discussed in detail during our theoretical classes. But this silly molding material, that is green sand mold, what we are utilizing in our workshop, in the last video we had observed, that was a black mass, right? And that was also not dry. So that includes so many ingredients. What are those ingredients? Actually, there are three ingredients basically. That is dry silica sand or dry sand, it is mixed with, so only dry sand will not serve the purpose. Now here, this molding sand contains 80 to 90 or many more, and basically silica sand or other quartz sand, maybe quartz sand, or any type of the required sand, what is required, but generally it is a silica sand. Okay. So what are the various desirable properties? This is in dry condition, okay? This is in dry condition. And sizes, you just observe the sand grains may vary in size from few micrometer to few millimeter. So micro to milli, or maybe some powdery mass may also be there. Okay. And some properties are desired because, like say, refractoriness is very important. Why? Then chemical resistivity, permeability. So these are important because there are many more. But what is refractoriness? When, say, we are preparing one mold cavity using some dry sand, using some molding sand, not dry, molding sand. So as soon as molten metal will be poured in that cavity, molten metal contains a tremendous amount of heat. If it is, say, steel, then heat will be at least 1400 degrees centigrade, melting point temperature of the metal. Okay. So molten metal will be poured at very high temperature. So getting that heat, the mold cavity, particularly the face portion where the molten metal is encountering for the first time, immediately the face will be affected, and those portions will be burnt out. And if the portions are burnt out, then what will happen? The part geometry will be altered, shape will be altered, dimension will be altered, and the product quality will be impaired. And as a result, the end product will have to be rejected. That is a waste. Right. So, a very important property is the refractoriness, that is, the ability to withstand very high temperature to protect from burning. So, other properties like chemical resistivity, it must not have some chemical reactivity with other, say, because molten metal may contain so many chemicals. So, it must not have some chemical reactivity. Permeability is the concept when molten metal will be poured. Molten metal contains various dissolved gases because there are alloying elements, some impurities. So due to all these, some dissolved gases will be generated. Okay. And molten metal contains very high temperature, as I have mentioned. So when that will come in contact with the molding sand is not a dry sand, as I have mentioned. It contains some other ingredients. Water is amongst them. I shall discuss what are the other constituents, but water is another component. So dry sand is added with some moisture also, or moisture in the form of water. Okay. So dry sand individually can't be used. If you take a handful of dry sand, can you give it a proper shape? No. So dry sand is mixed with some quantity of moisture. Again, there is a percentage. What is the percentage? 1.5 to 8%. We don't measure, but we can feel by virtue of our experience. We can understand what is the adequate amount. Too much of water will, again, make the total mass very liquid, and that can't be utilized. So we must prepare a dough. You understand what is dough. So sufficient, adequate amount, that is maybe approximately from 1.5 to 8%. We don't measure, but approximately this is the theoretical proportion. And 80 to 90% is the dry fraction of silica sand or other type of sand. And so before discussing permeability and some other property, let us complete our discussion of the molding material. What is green sand mold? Green sand mold contains dry silica sand, 80 to 90%, moisture, 1.5 to 8%, then some binders. Binders are nothing but having some adhesive quality, which will bind together all the ingredients. Okay, it will have some adhesive quantity. Now clay is naturally available binder. Clay is again a type of sand. It is further refined sand. More when sand, we understand what is sand after refinement, years after year, rock particles are fragmented and sand is produced. And whence again that sand is further refined, okay, and also mixed with some silt, right? The leaves, waste leaves, cotton, jutes, all the waste product of earth, then this material becomes almost plastic and a earthy material, naturally available earthy material. Okay, clay. So this clay is having some binding ability. Binding means some adhesive quality. It will bind all the ingredients together. So clay is already mixed with sand, naturally available sand, which is available from nature, is already mixed with clay. Some molding sand may contain this 5 to 20% of clay, which will give bonding strength. So molding sand contains is already natural sand is already mixed with clay, which is available from nature, and portion may be 5 to 20%. So dry sand, then mixed it with moisture, add some binders, and as I have mentioned, some properties are required, like enhanced capacity to withstand very high heat, chemical inertness, then permeability. Now, what is permeability? That I shall now discuss. Now, as I have mentioned, molten metal contains so many dissolved gases, and as molding material includes some moisture in the form of water. So when molten metal will be poured from very high temperature, readily some moisture or water will be evaporated. Gaseous steam will be formed, getting 100 degree of centigrade from that molten metal. So some steam will be formed. And not only that, atmospheric air will also be entrapped in this molding material, the molten metal. And all these gases and streams, air, atmospheric air, when will be dissolved with the molten metal, will be entrapped inside the mold cavity. And during solidification, they will try to escape. They will try to escape. So they will seek some openings through which they can escape, they can pass. If there is no room, then they will be entrapped inside the cavity or inside the cast part. And lot of defects will be generated. And various defects, casting defects are there. A majority of the defects are due to these entrapped gases or bubbles. Again, what are the different type of defects, how they are formed, how those defects can be minimized. You can't completely eradicate the defects. It is never possible, but we can minimize only by designing, etc., selecting proper material. So those will be discussed in theoretical classes at length. Right? So, but majority of the defects are due to these entrapped gases or bubbles. So task is to provide some passage through which the dissolved gases can come out. Now, fortunately, as I have mentioned, molding sand is a mixed mass and the different shapes and sizes are there. Not all circular, not all pentagonal, not all hexagonal, not all triangular. So that is a mixed mass. So from very powdery mass to very large fractions to medium, so it is a mixed mass. So when all these masses are aligned, so in between, say this is one particle fragment, one piece. Another piece is like say circle like this. So when they are united, they come in contact. Then in between, due to their shape, geometrical shape and size, there is a void space. Similarly, some other say smaller piece, some other pieces are there. So in between, there will be various internal voids, open portions. Those are the concept of permeability, open portions, porosity, permeability. So if the sand particles are very large in shape, larger sand particles, so permeability or porosity or openness will be high, and that will be in that case the gases will be easily can escape from those openings. But what will be the problem if the porosity is very high, that is openness is very high, that will result a very rough cast, very rough surface of the cast part. And if a very rough surface is generated, then again you will have to machine that surface for final finishing. Otherwise, again, that will not be accepted by the customer. So further operation, machining operation is needed. And not only that, that will also be associated with loss of material. MRE, you may use some other tools to separate those unwanted portions. But that is ultimately will give you the loss of material. On the contrary, if I use very fine powdery mass, that will give very high surface finish, smooth surface finish, but the compactness of the mold again will be very high. That is, there will be very little room or porosity will be very less. So gases will be entrapped. So airborne defects will be many more. So a balance is needed. That's why I must mention what is my requirement, that is shape of the sand particles, and that is given by GFN, grain fineness number. That is also a measure of permeability or porosity. There are techniques how that is measured. And also, now try to remember in our workshop video, in the last phase almost, if you can't remember, you may review the videos. There was one operation when the mold was prepared at the very last, almost on the last phase. A vent wire was taken, vent wire or a vent rod, very thin rod or wire, and some perforations were made on the top surface. Perforations. So that is, those sand particles are having porosity or permeability property, still we are mechanically or artificially creating some more passages for the easy or safe escape of the dissolved gases. Still then all the gases will not be escaped. Some will be entrapped. but we are providing some say passage using vent wire or vent rod. That is the concept of venting. And there is a guideline or rule of venting, how to vent. Again, you watch that video. Say if this is the, say, cope hub and this is the drag hub. Two hubs were used. In our workshop, there were two hubs. Can you tell me? We had used only one iron box as a top portion, that is cope. Top hub is known as cope hub or cope flask, and bottom flask is known as drag flask or drag hub. A similar casting will be used as a drag hub, but in that workshop video, there was no bottom hub, but there was sand bed or floor of the workshop, floor containing the sand, right? So floor itself served the purpose of a drag hub. So on this floor, the, say, pattern was placed. In the first job, what was the name of the pattern, or what was the job? No response.
স্যার ওটা তো ওই পরে তুলে নেওয়ার জন্য যাতে
What is the name of the job?
ও
Where is role 1? Nobody. So if you follow this practice, then obviously, because there will be a viva, as I have mentioned, this workshop includes 100 marks. 50 is meant for job, 20 is for attendance come performance. So regularly I shall ask you questions. So how, whether you are listening carefully or watching videos or only just time passing. So 50 plus 20 and then 30 is meant for the central viva. So all inclusive mark will be given. So if you want to score better mark, then obviously you must be very alert. This is very simple question. I am not asking any theory, difficult theory. Anybody, what was the name? Because one complete day, that is almost 1.5 hours plus, was meant for observing the video. Not only that, I told you to observe the video time and again, but you don't know the name of the job.
Hello,
what
sir.
you are doing.
Sir.
Not a single person.
Hello, sir.
Bolo.
Gear handle of lathe, sir.
Not even gear handle. Reversing gear handle of a lathe.
Reversing gear handle, yes, sir.
So not only this, you had that pattern in your pattern making shop. Wooden pattern was made, right? So you should remember. And what was the other job, the second job? Anybody? Palmer block cap. Palmer block cap. Palmer block cap. So again, what is Palmer block? You should know, because that is also a very important part of a for mechanical engineers. There is Palmer block cap and bottom. So altogether is used to hold this any shaft, rotating shaft, to avoid from bending and others, right? So but only the top portion, cap portion, was fabricated here. Okay, so you should remember. Now floor was served. So the job was placed somehow here, and you insert from the cope, you insert the vent wire and try to, what is the rule of venting, how the vent wire is to be used is very important. You touch the, this is the vent wire, even just a long stick. Okay. Now insert this vent wire through this scope box and try to touch the topmost portion of the pattern. So if this is the pattern, try to topmost portion of the pattern. If the pattern looks like this, say pattern is like this, you are using a pattern which is having a shape like this. Then where to place the vent wire? For the first time, you try insert the vent wire and try to touch the top land, not here, not here, again not here. All these are at different levels. All these are at different levels. Try to fill the top portion and then take out this vent wire. You mark this portion, you just mark this portion up to which you are filling the top land, top height of the job, and then grip here and take out this vent wire. Then if this is the length you are marking, that this is a total length, you hold here and take out the vent wire and then grip somewhere here. This is your mark where the top land has been touched. Then reduce this length by some amount, at least 1/3, and grip here, pick the tool here, and then go on perforating in different all the copper. Why this is so? Because if you use the total length or say this length or this length and perforate throughout, then number of times these holes will touch this top land also. Okay, and later on when molten metal will be poured, metal will also enter through these capillary holes. These are very fine holes, capillary almost. So after solidification, what will happen? Say if this is my desired surface, then there will be some protruded portions, capillary, very thin portions, and these are known as fins. And that is a defect, casting defects. Fin is a casting defect. So again, you will have to remove all these protruded portion by machining or other operation. So again, that is time consuming, machines are required, manpower is required, wastage of material because this material will be rejected. So this is the rule of venting. So if I ask you what is venting, you should answer. Why it is done? Again, to provide more passage of the dissolved gases, entrapped gases. And what is the rule of venting? This is the rule. That is, fill the top land of the job, of the pattern, then reduce the height by some amount so that the vent wire never touches the surface of the pattern. But cope is having so many perforations. Okay. So these are the ingredients. Now this dry sand is mixed with some moisture or water, added with binder, and so all these three are very important. All these are required. At least without these three, dry sand must be mixed with some moisture and some binder. If natural sand is used, then you need not add any additional binder because natural sand already contains some naturally available binder, which is clay. But for good quality casting, for mechanized industries, you should use dry sand of a particular type. Say zircon sand may have to be used, chromite sand may have to be used, chrome and chrome magnesite sand may have to be used. So what are the difference? Because that is not silica, that is coming from some other rocks, and those are having some desired properties. That's why we are using those synthetic sands. So high quality, any type of dry sand, if for good quality casting, it is not mixed with natural clay. So in that case, dry sand is mixed with some binders. There are various types of, again, binders available, organic or inorganic binders. You read books, because that is also the need or requirement of the theoretical classes. So what are the different binders? Organic binders, inorganic binders, bentonite clay, kaolinite clay, all synthetic binders. Molasses is also considered as a binder, but not a good quality binder, because molasses, that is a byproduct during the production of sugar cane, during the production of sugar from sugar cane in sugar industries. Thick liquid, dark solid, thick liquid, dark thick liquid, viscous, and that is highly hygroscopic in nature, molasses. So it will readily absorb moisture from atmosphere. So that initially they may give good binding, but after some time, when they will absorb moisture from the atmosphere, so they will be relaxed. Okay, mass will be relaxed. So we may not get good quality casting. So for good quality casting, molasses are not preferred, but obviously that is less costly compared to other synthetic binder. So anyways, so we must have dry sand, moisture and binder. These are the essential minimum. But sometime, or for very good quality castings, another component that is known as additives are to be used. Additives means some other chemicals which are added in some quantity to increase some properties. All the sands may not have refractoriness properties, good refractoriness properties. All the sand may not be chemically inert. All the sands may not have some other qualities like strength, high surface finish, etc. quality. So to provide all these say properties, or to enhance those properties, to increase refractoriness, for smooth surface finish, some additional materials are to be added. So those are known as additives. But you may proceed without additives also if you don't require the quality. But if some properties are to be enhanced, then some additives are to be added. Okay, so there are various additives. So again, you go through books, what are the additives, what, in which case, which additives are to be used. So when all these ingredients are mixed thoroughly, a dough is produced, right? So that is the molding sand. And as dry sand is mixed with moisture particularly, that is the concept of green sand mold. So what we used to say, green sand molding. Now green sand doesn't mean the color is green. Green sand means it is mixed with moisture. Okay, only dry sand can't be used as a molding material. So when it is mixed with moisture and other ingredients, that is the concept of green sand, and that is a molding material. So in our workshop, that is a green sand molding process. So these are some additives, as I have mentioned. Some additives, materials other than basic materials to improve some properties. Coal dust, silica flour, say wood flour, different cereals, cellulose. Okay. Some additives, molasses are also considered sometimes as a binder or as additive, then ethylene glycol. Iron oxide, silica. When iron oxide or silica is needed, if hot strength is required. That is strength at very high temperature. If good surface finish and resistance to metal penetration is required, then coal dust silica flour is needed. Okay. So in this way, there are many more. So this is just in a nutshell. So as I have mentioned, there are various types of molding sand. Naturally available sand is known as natural sand, and also called green sand because it is already mixed with some water. But the concept of green sand is something different. Natural sand is available in nature, which is already mixed with moisture as well as clay. That's why it is also called green sand sometime. But the concept of green sand is something different in our case, because what sand we are using in workshop, that is not natural, that is dry silica sand mixed with clay or some additives, mixed with some mixed with clay or some binders, mixed with some additives like coal dust. That's why the color becomes dark or black, and it is also mixed with some added amount of water. Okay. But when naturally available sand, that is natural sand, is used, that is already mixed with clay and water. That's why they may call the green sand also. And what are the advantage? This is cheap in nature, available in nature. No extra equipment is needed for mixing. We can readily utilize, no extra time for mixing. But disadvantage, they are not having some desired properties like less refractory, or there are some impurities are also present, etc. So some ordinary castings, they are used. But synthetic sand means synthetically produced. It is free from clay or other impurities. Okay, what are the advantage? High permeability and refractoriness, less moisture with moldability. Disadvantage is costly, extra time is needed, extra equipment is needed, extra manpower is needed. And what is application? For good quality casting, heavy casting, require some specialized castings. And some special, as I have mentioned, it depends on the type of rocks. Not only quartz or silica particles, but we may have zircon rock, zircon sand, zirconium silicate. It is coming from a rock which contains zirconium silicate. Olivine sand is coming from this orthosilicate of iron and manganese. This is the formula, orthosilicate of iron and manganese. So that is known as olivine sand. So that is having another some properties. Chamot sand. This is high grade fire clay. It can withstand 11,000 degrees centigrade. Sorry, not 11,000, 1100 degrees centigrade. This is degree. Okay. Chromite and chrome magnesite. So that is another special type of. So all these are costly also. Accordingly, we have some other. So now, from the application point of view, we are distinguishing the sand in different categories. Like green sand, we already have mentioned. Any dry silica sand mixed with some quantity of clay, 18 to 30% of clay as a binder, some water, 6 to 8% or 1.5 to 8%, what was mentioned earlier. And as it is mixed with binder as well as moisture, this is known as green sand. And what is dry sand? Is the concept is something different. When this green sand is prepared, or green sand green sand mold is prepared using green sand mass, then it is baked in an oven or it is dried in atmosphere. So what will happen? Moisture part will be evaporated, and that mass will be considered as the dry sand. But remember, if you take a wet sand that is mixed with water and then dry it, that is also free from moisture, but you can't prepare any mold utilizing that sand. That concept is something different. But dry sand here means you are taking green sand, you are preparing a mold using green sand. So now mold is prepared. Remember, in our case, we had prepared one mold using green sand. And now if that particular mold is baked in an oven, or you place in open atmosphere, so getting heat from the sun or from atmosphere, the moisture part will be evaporated after so many time. And that remaining mass is very hard, and that is the concept of dry sand mass. But using only dry sand, you can't prepare a mold cavity. You should remember. Now, what is loam sand? Loam sand is mixed with 50% clay instead of 80 to 30, 50% clay. Now, what is the advantage? As more clay is added, when it is baked or dried, the mass will become very hard. And not only this, for very large casting, which requires a lot of molding material. Now, if I want to produce the total casting utilizing a good quality sand, that is highly costly. So that is cost prohibitive. So to reduce cost, I may reduce the portion of sand and fill it with some clay. So 50% clay. Clay is not that costly. So this is the concept of loam sand for large casting. Facing sand means, as we have mentioned, the faces, the open portion of the cavity. You remember the cavity, how it was produced, taking out the pattern from the drag or cope hub. Then the cavity was produced. The front portions are known as the faces. And when molten metal is poured from top at very high temperature, the face portion are the first line. So the heat will directly affect the face portion. Then it will percolate to the inner portion. So face will be affected severely, getting that heat. So if ordinary sands are used, then immediately those sands will burn out. Or when molten metal will be poured from some elevated height, it will apply some metallostatic pressure, and by virtue of that pressure, the face portions may wash out if the ramming is not proper. That is the question of strength, green strength. So to provide some properties in the first line defender, that is the face. They must have some refractoriness, enhanced refractoriness property, that is ability to withstand high heat, right? And also the strength, that is green strength, must be very high also. Otherwise metallostatic pressure of the molten metal will wash them out. The dimension will be altered. So to enhance those properties, facing sand must have some desired properties. So after preparing the total cavity using ordinary green sand, we may apply facing sand separately in the face portion only. So that is the facing sand. Obviously the cost is high. So that is the facing sand. What is backing sand now? As the total mold is not prepared with facing sand, because due to the cost, if it is prepared with facing sand or good quality sand, that is obviously the best. But due to cost, we can't do that. So the backup is prepared with some sand which is known as backing sand to fill the total flask. You just remember the other day the video was we observed the video. So the total flask was filled with some sand. So ordinary sand was used to fill the total flask. So that is the backing. And this is already used sand. Say after pouring the molten metal, some portion will be burnt out. Then again that mold will be have to be broken. So again that sand will be remixed and will be used as a backing sand, not for good quality but for backing sand. And as the molten metal will be poured, some portions will be burnt out, coal is already mixed with this. So after reuse, the color becomes black. So that is also known as black sand. Either backing sand, also known as black sand. Now in mechanized foundry, where there is no manual intervention, this backing sand or black sand is called a system sand. Same concept, but in mechanized foundry, this backing sand or black sand is known as system sand. What is parting sand? Now again you remember, we in our workshop we had not used facing sand, or we had not introduced any concept about backing sand separately. We had mentioned green sand, right? But facing sand, now you understand what is facing sand. What is parting sand? That was introduced. Say after preparation of the cope, after preparation of the drag or floor portion, then the cope will be inserted on that portion. But before placing the cope hub, some parting sand is nothing but dry silica sand, good quality, finely powdered dry silica sand. Officially, this is the definition, but in our workshop, we just sprinkled or sprayed some ordinary dry sand. Why? Just to avoid sticking in between the two hubs, cope hub and drag hub. What is the example? When the handmade braids are produced in house, you might be familiar with. What we used to do? After preparation of a single braid, we are placing on a dish and then we are sprinkling some dry flour, wheat flour, and again placing another on that. Again we are sprinkling some dry flour, again, just to avoid sticking of the two halves. So that is the parting sand, a powdery sand. It is a dried silica sand, good quality sand. Core sand, core is something where in our workshop, in the first job, we have reversing gear handle of lathe, and there in that pattern, some 1, 2, 3, 4 protruded parts were there. Three were in cylindrical in form shape. Other was some curved part. So protruded portion. They were prepared separately in the pattern shop, and using some nails, mallet, they were fixed on the pattern, main pattern. So those were core prints. And when these core prints along with the pattern was used in the cope and drag hub system, then after the withdrawal of the pattern, what were there? Some recesses were produced. You remember, or if you can't remember, you watch the video once again. Some cylindrical recesses were produced. What is the need of that? Now, on those recesses, later on, we shall introduce some solid blocks, maybe produced with some green sand, that is known as core sand, to make a core. Either it is prepared with core sand or some metal or some wood, just to restrict the flow of molten metal in those portions. If some obstacles are placed on those portions, then when molten metal will be poured, they will not be able to enter on those portions. Why it is needed? Because we don't want molten metal to flow on those portions. I want hollow provisions on those portions, because later on that part will be fitted in the lathe, which requires some hollow portions. If it is a completely solid, then also that can be used, but in that case I will have to drill, make holes. So that is again tedious. Wastage of material, time consuming, machine consuming, manpower requirement, all these. That's why cores are provided. And what is used on the pattern is known as core prints. Core prints are used to provide seat of the core. All these are important points, what I am talking. All these are included in your theoretical classes. So core prints, two different terms. Core prints are placed on the pattern, whereas cores are placed on the mold to restrict the flow of molten metal on those desired portions. Now tell me, what is green sand core? Anybody? Green sand core.
স্যার 18% ক্লে থাকে ওইটা।
Green sand core. Have you observed the workshop video in your home or in the other first class? So where is 4, roll 4? Roll 4. 5. Roll 4 is present or no?
Roll 5.
Roll 4, where is roll 4? Otherwise I am marking absent against roll 4. Roll 4, Shobhan Maiti, are you present? Roll 4 in the chat box. Roll 4 is absent.
It's not responding.
So roll 4 is absent. Whether roll 4?
স্যার প্রেজেন্ট আছি।
Who is অনন্য সুন্দর নস্কর? অরণ্য শুভ্র নস্কর?
Yes, sir.
Why are you asking whether record হচ্ছে তো ক্লাসটা? Who told you to record this class?
Actually, sir, না না স্যার, এটা আপনাকে বলিনি, মানে আমাদের নিজেদের এন্ড থেকে ক্লাসটা
তোমরা
রেকর্ড করে
নিজেদের
যদি
কেন
কারোর
রেকর্ড
কোনো
করবে কেন?
প্রবলেম
আমি
হয়েছে।
রেকর্ড করতে দেবো না। আমাকে জিজ্ঞেস করে করছো রেকর্ড?
সরি স্যার।
You tell me what we are discussing. What I told last, tell me.
Sir, green sand core. Sir, you are asking us that what is green sand core, sir.
So tell what is green sand core?
Sir, I don't have the clear idea, but it is a binder, sir.
Why
it has
you
created-
are interested to record classes and all this? Why are you not watching?
Sir,
Why are you not taking notes what I am telling?
Sir, we are watching, sir, but sometimes in online mode, sir, sometimes the networks are gone, or something. Many types of problems are happening, sir. That's why we.
So have you
record the
observed the videos? What I get the link in the last
Yes,
class?
sir, I have watched the first video, sir.
Why not the second? All the first and second are in together, the foundry. So in that video, it was clearly mentioned, particularly for that only that job was demonstrated, just to demonstrate what is green sand core. So all of you watch the video and answer me what is green sand core in the next class. Only for that particular demonstration, the second job was demonstrated, especially for that point only. And neither of you had observed. And where is role 4?
হ্যাঁ স্যার বলুন।
Mighty is absent today.
হ্যাঁ স্যার, আমার নেটওয়ার্ক প্রবলেম হচ্ছে একটু। ভাই প্রেজেন্ট হচ্ছে না কেন?
So try to rectify your network. Today I am giving you then roll 1, roll 2, roll 3, 4, 5, roll 5, roll 5. Where is roll 5?
5 sir, roll 5. Hello.
Roll 6, 7, 9.
Yes, sir.
11,
Yes, sir.
22, 23,
Yes, sir.
26,
Yes, sir.
27,
Present, sir.
30,
প্রেজেন্ট স্যার।
31, 32, sorry, 38, 38,
Present, sir.
39,
Present, sir.
42,
Present, sir.
47, 48,
প্রেজেন্ট স্যার।
1001, 1001, 1002,
Yes, sir. Present, sir.
1003.
Yes, sir. Present, sir.
Where is 1001? Huh? 1001. Whether 1001 is present? 1001 is absent. is absent. So anyway, so this is green sand. So we have mentioned system sand, then core sand and all these. So core sand, again green sand core, you tell me what is green sand core in the next class. So in the next class, again we shall discuss some other theoretical aspects and along with some tools used. So all these are ordinary and simple. So again, these will be discussed in the next class also. So any question up to this? Any question?
Sir, can you share us the slides?
No. You read books, you observe videos. I don't used to give notes or other things. Any other question? So if you don't have any question, we may quit for today. So again on next Thursday, again I shall give you link. So join in that class again. So what is that date? Today is 27. Third. Okay, third is not a holiday. So third we shall join. Okay.
Okay, sir.
Okay, sir.